Well, good morning, children. So let us continue with the lesson solutions and move ahead with other topics. Okay. So now, first of all, I'll start with a few corrections, or so I put it as corrigendum. So corrections in the previous videos, and then I'll move on to the next topic. Okay. So there was a question: if N2 gas is bubbled. So I'm not reading the whole question. Okay. So you can just find it out. So number of moles of nitrogen is equal to 7.16 into 10 to the power minus 4 moles. So we were to calculate it in millimoles. So 7.16 into 10 to the power minus 4 into 10 to the power 3 millimoles. Is it clear? So I had actually written it as minus 3 by mistake, it seems. Okay. Now, second thing, pressure has little or no effect, okay, on in the solution of solids in liquids, because solids and liquids are highly incompressible. I had given compressible, I think. Okay, it is incompressible. Okay. And the third question, there was a question for KH for CO2, in which there was 500 ml soda water. So I had written it as 0.51. I calculated it. It is, I think, one of the student also had told me that it is 1.51 into 10 to the power minus 3. I had written it as 0.51 into 10 to the power minus 3. Is it clear? Okay, fine. So now the other day we had stopped with one of the problems with the topic that is to find out the mole fraction of the components in the vapor phase. If I am right, you can recollect it as Y to P1 is equal to Y1 into P total. So that equation. Okay, so I am taking one problem on that topic. Okay, what is that topic? To find out the composition of the vapors. Okay, or to find out the composition of the two components. Okay, or the mole fraction of the two components in vapor phase. Till now we were doing in liquid phase. Now it is in vapor phase. Okay, so the question is, vapor pressure of chloroform CHCl3 and dichloromethane CH2Cl2 at 298 K are 200 and 400. No, it's not 400, 415. Okay, sorry, it is 415. Okay, 415 mmHg. Okay, so I'll just put it as 415. Okay, so this is 415 mmHg. Okay, calculate the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of CH2Cl2. Okay, so once again, the vapor pressure of chloroform and dichloromethane at 298 K are 200 and 450 mmHg. Calculate. This question contains two parts. The first part is the vapor pressure of the solution prepared by mixing 25.5 gram of chloroform and 40 gram of dichloromethane. So we start with the question answer. Okay. So now, first of all, we have to find out the number of moles of, since we have to find out the mole fraction, we have to find out the number of moles of chloroform. Number of moles of chloroform is equal to 25.5, that is weight in grams divided by 119.5. Can you guess what is this 119.5? The molar mass of chloroform. Okay, the molar mass of chloroform. Is it clear? Now likewise, we are finding out the number of moles of dichloromethane, 40 divided by 85. So naturally, what is 85? The molar mass of CH2Cl2. So we are getting it as 0.213 mole here and 0.747 mole over here. So total number of moles is equal to 0.683 moles. Okay, 0.683 moles. Okay. Now, X, that is number of the mole fraction of CHCl3 is equal to NCH3 divided by N total. So this is, so now it is self-explanatory. Number of moles of this chloroform divided by N total. So we are getting it like this. Okay, 0.312. So let us move forward. And X CH2Cl2, we are not to find it out like that, but we can take it as 1 minus 0.312, that is equal to 0.688 moles. I hope this part is very clear. Okay, so now in the last video I had taken, if you want to find out P total in terms of XB, you can use this equation. P total is equal to P0A plus P0B minus P0A into XB. So that is 200 plus 415 minus 200 into 0.688. I have always told you that A is always the solvent and B is the solute. Okay, so we are getting it like this: 200 plus 415 minus 200 into 0.688. So we are getting it as 200 plus 147.9 and we are getting it as 347.92 mmHg. Is it clear? So this was the first part. Okay. Now second part, find out the mole fraction of each component in vapor phase. That means you have to find out Y, A and YB. Is it clear? So now how do we start? PCHCl3 is equal to P0CHCl3 into XCHCl3. So we have got it as 62.4. Now YCHCl3 is equal to PCHCl3 divided by P total. Already we have P total with us and we didn't have PCHCl3. That is why we have found it out from the equation PA is equal to P0A into XA, that formula. Okay. So we are getting it as 0.18 moles. Is it clear? Okay. So now next we are moving forward. We are again finding the PCH2Cl2. Okay. That is equal to once again P0A into XA, okay, or P0B into XB. So that is 415 into 0.688. So we are getting it as 285.5 mmHg. Okay. Now YCH2Cl2 is equal to PCH2Cl2 divided by P total. So what did we get PCH2Cl2 as? 285.5 divided by 347.9, that is equal to 0.82. So see, now we have got all the things. Okay, the composition in the vapor phase. So what is the composition of chloroform in the vapor phase? That means when we are taking this solution of these two components and when they are forming vapors, in this vapor how much of chloroform is there? That is what we have got. YCHCl3 is equal to 0.18 Y. Okay, and what is the composition here? In the solution it is X, but in the vapor form it is Y. So we have got it as YCHCl3 is equal to 0.18 and YCH2Cl2 is equal to 0.82. That is, the vapor phase is richer in CH2Cl2. Okay. See, we are getting it as 0.82. Okay. At equilibrium, vapor phase is always rich in the component which is more volatile. Okay. So from the question itself, we can get to know that this is more volatile because the vapor pressure of this dichloromethane is 415 mmHg. From that itself, we can get to know. So when we solve out, we should also get it in the same way. Is it clear? So now let us move on to the next topic. So the next topic is an ideal solution. What is meant by an ideal solution? That is the next topic. Now try to understand this. And if you are able to understand this, sometimes it comes as a 5-mark question, essay question, and you can do it very well. Okay. So let us move on to what is ideal solution. So solutions which obey Raoult's law under all conditions of temperature and concentration. Okay. So solutions which obey Raoult's law under all conditions of temperature and it's not pressure and concentration is known as an ideal solution. That means there are a few criteria which should be followed by a solution if it is to be called as an ideal solution. So let us see what. So it is obeying Raoult's law. So in that case, PA is equal to P0A into XA. PB is equal to, okay, P0B into XB and P total is equal to PA plus PB. Is it clear? Now, delta H mixing is equal to 0. Okay, delta H mixing is equal to 0. That means heat is neither released nor absorbed during the formation of an ideal solution from its components. And also delta V mixing is equal to 0. That means there is no increase or decrease in volume during the formation of an ideal equation. That means if I am adding 25 ml of A to 25 ml of B, I am getting only 50 ml. It's not 48 or it's not 51. I'm getting only 50 ml. That means delta V mixing. Okay. It is change in the volume that is equal to 0. Okay, now look here. If such a thing has to happen, in that case, we say that if you are making that solution from two components A and B, that means that it means that the interaction between A and the interaction between B and B separately is equal to the AB interaction when they are coming into the solution. Is it clear? When A is all alone, it has got AA interaction. Okay, there is a bond between A and A, so we call it as AA interaction. And then in B, it has got BB interaction. And now when we are mixing it together, AA interaction should be equal to BB interaction and both should be equal to AB interaction. In that case only two components can form an ideal solution. Are you able to understand? So if there is a 1 mark question, so what are the criteria of the two components to form an ideal solution? You can say similar structure. What do you mean when I say similar structure? Similar structure means they must have at least a similar atomic size or atomic radii, okay? And polarity. What does polarity means? The interaction, okay? The molecular interaction between AA and BB must be equal to AB, okay? It should all be similar or same. Is it clear? So all those substances which are having similar structure and polarity, when they are mixed together, they form an ideal solution. And what are the conditions? PA is equal to P0 A into XA, PB is equal to P0 B into XB, and P total is this. Delta H mixing is equal to 0, delta V mixing is equal to 0. Is it clear? So now, the solutions which do not obey Raoult's law, if these conditions are not obeyed by any solution, in that case we call those solutions as non-ideal solutions. Is it clear? So we call them as non-ideal solutions. So when a solution does not obey Raoult's law under entire ranges, see, entire ranges of temperature and concentration, it is called a non-ideal solution. Are you able to understand? Okay, so now let us move further. Now, non-ideal solution show either positive or negative deviation from ideal behavior. Are you able to understand? Non-ideal solution show either positive or negative deviation from Raoult's law. Is it clear? So now, we have to study it under two headings. The first one is non-ideal solutions showing positive deviation, and the second one is non-ideal solutions showing negative deviation. Okay, so before I get into this ideal and non-ideal behavior, I want to tell you that a solution of normal hexane and normal heptane, a solution of benzene and toluene, a solution of ethyl bromide and ethyl iodide. See, these are all ideal solutions. So once again, a solution of normal hexane and normal heptane, a solution of benzene and toluene, and also a solution of ethyl bromide and ethyl iodide. Okay, they are all ideal solutions. Okay, so now I am going into some solutions which are non-ideal solutions. So there are solutions like non-ideal solutions showing positive deviation and negative deviation. So let us take the first one, the non-ideal solutions showing positive deviation. Okay, so in that case, it is formed by two components A and B, wherein AA interaction is strong, BB interaction is strong. But when they form a solution in which A is also there and B is also there, the AB interaction is very weak. See, can you see this long bond that I have formed, which shows that the bond is very weak. AA is strong, BB is strong, but AB interaction is weak. Now, if this AB interaction is weak, when such a solution is heated, the vapor pressure would be high. Is it clear? The vapor pressure would be very high. There is more vapor pressure, or the vapor pressure is very high, because the bond between A and B is very weak, so they can easily evaporate and easily form vapors. Is it clear? Now, delta H mixing is greater than 0. That means it is positive. Are you able to understand? Delta H mixing is greater than 0 means delta H mixing is positive, because energy is needed to break the strong bonds. I told you AA and BB bonds are very strong, but AB bond is weak. So in order to break this AA and BB bond, we require tremendous amount of energy. That means energy has to be supplied. That is, delta H mixing is greater than 0, and therefore the delta H mixing is positive. Similarly, delta V mixing is also positive. Now look here, if I am taking 25 ml of A and 25 ml of B, since the bond is very weak, when we form the solution out of these two components, maybe the solution is 55 ml. Why? Because the bond between A and B is very weak. That means delta V mixing is greater than 0, and it is positive. Because there is decrease in magnitude of the intermolecular force. Is it clear? I told this bond is weak. The molecules are held loosely and there is increase in volume. Are you all able to understand it very well? So in that case, I'm going to write down the conditions, or I'm going to describe the conditions that is there when two components form a non-ideal solution showing positive deviation. PA is greater than P0A into XA, PB is greater than P0B into XB, and P total is greater than PA plus PB. Number 2, delta H mixing is greater than 0, and next is delta V mixing is greater than 0. Is it clear? So I'm just giving you one example. Cyclohexane and ethyl alcohol. So in your board examination, if it is asked cyclohexane and ethyl alcohol, what type of a solution do they form? They form a non-ideal solution showing positive deviation. Okay. Now see, some molecules of cyclohexane tend to occupy. What happens is that when these two things are mixed together, ethyl alcohol molecules, they are held together with strong hydrogen bond. Because in ethyl alcohol, there is oxygen atom as well as hydrogen atom. So ethyl molecules are held very strongly. So now, when we are mixing them together, some molecules of cyclohexane tend to occupy the space between the alcohol molecules, which were held by strong hydrogen bonds. Okay, and what happens is that the intermolecular forces are weakened and the solution shows positive deviation. Is it clear? So now, once again we have to draw the same Raoult's law graph, and this was XA is equal to 0, XA is equal to 1, and here it is XB is equal to 1, XB is equal to, you have to draw it, okay, and here it is XB is equal to 0. The graph, okay, so you can draw it from the book also, and this is that graph. But in every graph, this dotted line, it should be, see, if this is a line, we are showing it with dotted line. What is this? Positive deviation, okay. So all the lines, they are marked by this sort of a dotted line, which shows that this is the graph for PA, this is the graph for PB, and this is the graph for P total. So I had already drawn this. And in that, vapor pressure XA is equal to 0, XA is equal to 1, XB is equal to 0, XB is equal to 1. Okay, we have to do it like this, and all these graphs. And above all these graphs, we have to draw it like this. Okay, so next, if it is like this, so we have to put it like this. So we are showing positive deviation. That means when they are forming a solution, the vapor pressure is very high as compared to that of the ideal behavior. Is it clear? So give an example of a solution showing positive deviation, cyclohexane and ethyl alcohol. That is what we are giving the example as. Okay. Now see, next one. Non-ideal solution showing non-ideal solution showing negative deviation. Okay, now in such a deviation, the partial vapor pressure of each component of the solution is less than the total vapor pressure as expected according to Raoult's law. That means the vapor pressure or total vapor pressure also, it is less than we are expecting. Is it clear? So can you guess why? Because AA interaction may be weak, BB interaction may be weak, but when they are coming into the solution, this AB interaction might be becoming very strong. So in that case, these molecules have very less tendency to go into the vapor state. Is it clear? And if they are not going easily into the vapor state, the vapor pressure is less than expected. So in that case, they will be showing negative deviation. Is it clear? So let us see. In such cases, AA interaction is weak, BB interaction is weak, but when it becomes AB interaction, that interaction is very strong. The escaping tendency of the liquid decreases. See, the components are not able to vaporize easily. The escaping tendency, escaping means from the liquid phase getting converted into the vapor phase. The escaping tendency of the liquid decreases, which results in the decrease in their partial vapor pressure. That means delta H mixing is less than 0. Less than 0 means it is negative. It is negative. That means what? Energy is released. And you have learned whenever strong bonds are formed, energy is always released. So in this case, delta H mixing is less than 0 means it is negative, and negative sign of delta H means energy is released. It is an exothermic process. Are you able to understand? Likewise, delta V mixing is 0. is less than 0. That means if I am taking 25 ml of A and adding 25 ml of B to it, since this A and B are forming very strong bonds, the total volume is not 50 ml but only 48 ml. Is it clear? So, and also, see, del PA is less than P0A into XA and PB is less than P0B into XB, and P total is less than PA plus PB. Are you able to understand? I hope this part is very, very clear to you now. Is it clear? So now let us go. What would be the next thing that I am going to take? It is the graph. So before taking the graph, let me talk about the example. Okay, example of a solution showing negative deviation is chloroform and acetone. Chloroform is CHCl3 and acetone is CH3 C double bond O and CH3. Okay, C double bond O and CH3. Is it clear? So this is it. So now when chloroform and acetone, they are coming closer, this H and this O, they are forming a strong hydrogen bond. Is it clear? And what are we doing here? The same graph, the vapor pressure, okay, and the mole fraction X. The graph, we have tried it as the mole fraction X, and what are we doing? The mole fraction X, okay, and this is the graph. So XA is equal to 0, XA is equal to 1, XB is equal to 0, XB is equal to 1. We are drawing the graph. This is the graph of PA, this is the graph of PB, and this is the graph of P total, okay. But everywhere, see what am I doing? I am putting the dotted lines like this. Are you able to understand? The dotted lines showing negative deviation. For positive deviation, what were we doing? We were putting like this. Is it clear? But for negative deviation, we are putting it below the graph. Are you able to understand? Okay. So that is the example. Is it clear? So, dear students, I hope this portion regarding that corrigendum and other topics, it is very, very clear to you. In the next topic, next video, I am going to talk about the azeotropes. Is it clear? So if you have got any doubt, you have to ask me, okay?